Hi, I'm Andrea and welcome to Productive C#. In this video I want to talk about how to implement locking using C#. So here I have a simple class called bank account that has a property called balance and two methods, one for deposit an amount and one to withdraw something. And those methods basically change the balance by adding the amount or subtracting the amount. So there is nothing wrong with this class. This class works perfectly fine if you use this class in a single thread. However, when you start using this class in a multi-threaded way, you will notice something interesting. I'm going to show you now. Here I have a program that creates a bank account. I'm creating a list of tasks, and I create 10 tasks that deposit 1,000 pounds or whatever into the bank account, and 10 tasks that withdraw 500 from the bank account. Okay, so what would you expect at the end of the code? So I wait all the tasks to finish, and I would expect the balance to be like I do 10 times 1,000, so it's going to be 10,000, and then I subtract 10,500, so I subtract 5,000. So I would expect 5,000 as the balance at the end of the execution. So what we are doing here, we are running effectively 20 tasks at the same time simultaneously, all of them calling deposit and withdraw methods, and at the end we check the balance. Okay, let's run this application and see what the result is. I run it and I get 5,500. all right, that's definitely not what we expect. What if I run it again? Now I get minus 500. Oh, that's really weird. Let's try to run it again. Now I get 4,000. And now I get 4,000. Now I get 5,000. All right, this is the right answer. Okay, so clearly the application is not reliable. So something weird going on. So when you work with multi-threaded applications, all the time you have some variables that are shared in between threads, you can basically end up in a corrupted state, because multiple threads can change that variable at the same time. And the order of execution of the task is unknown until a runtime. And so you can end up in race conditions where the variable is updated in the wrong way. So the only way to really solve this problem, so the best way to solve this problem, is make sure that the shared variables are accessed in an atomic way. So what do I mean with atomic? I mean that you want to make sure that only one thread at a time can, in this case, touch the balance at one point. So you want to avoid that other threads do operation on the balance while another thread is working. So in C#, if you want to do that, you use the monitor class. So let me see how to use that. So you do monitor.enter. And then you need to provide an object. This object is what is called like the lock object. So this can be any reference type. It's sort of a key. It's sort of a key that you say, okay, I'm gonna lock using this key. The best practice is to create a private field, private read-only object. That is, let's call it lock object. All right. Then I create an object. So this is one of those scenarios where creating an object is legitimate. And then you pass this to the monitor enter. And then you do monitor exit, passing the lock object again. Okay, and then you want to do the same operation in both methods. So what we are saying here is that I'm saying that everything between enter and exit will be executed atomically. So only one thread at a time will be able to run either this or this at the same time. And the reason why this is the case is because I'm using lock object in both cases. So if you use a different lock object in this case, I would basically make sure that only this is atomic, but not both together at the same time. So what I'm doing here is everything that touch balance is wrapped around these two calls. Okay. However, there are some problems with this code. So if I run it, you're going to see that it's probably going to work 5,000. If I run it, still 5,000, still 5,000. Now it's a lot more reliable, right? However, there are still situations when this code is not completely safe. Let's say if I throw an exception in the middle of this operation. Let's say at the moment I'm running something simple, I'm just simply updating a balance, but what if that code is slightly more complicated and it might throw an exception? What happens in that case is that we will never call monitor exit. So that means that one of the tasks that is running this code is effectively throwing an exception, so that all the other tasks waiting to actually enter inside this code will never be able to do so, because the task that acquired the lock will never release it. So let's see if I run it, what happened. As you can see, the application never stopped. It's basically completely locked. So this situation is called deadlocks, and it can happen in multi-threaded application when some synchronization is not working correctly, and one task is basically all the tasks are waiting for a lock to be released, but that lock will never be released for some particular case. In this case, it's for just an exception. In other cases, could be because of we use multiple locks, and there might be a deadlock, like task mutually waiting for themselves. And in any case, so what you want to do here to fix the problem is make sure that the exit operation always happens regardless of what this code does. And we know that the best way to do this is using the try and finally. So I do like a try, and then I do a finally. So I move all this code here, and I move the exit inside the finally. Right? I can do exactly the same for withdraw while subtracting. So now I know that if something goes wrong here, an exception is thrown, for example, I will still call the exit. So I make sure that the other task can carry on their operation. Okay, so now we are a bit more protected. Finally, there is still a situation when this code is not completely thread safe. That's the terminology that we usually use to say that some code can be used in a multi-threading context in a safe way. It's still possible that a task throws an exception while doing the enter. So it might be possible that we get to the finally here, but the lock was never acquired. It's very unlikely, but it could happen. And that's why Microsoft added another parameter to the monitor.enter function that basically is a Boolean variable that is set to true when the lock has been taken. So let's actually do that. So let's create a Boolean variable here, lock taken. Right, I set it to false. Then I pass this one here. And now what I can do is I do an if lock taken, and then I call the exit. So this is actually the correct code you want to use when you want to protect a particular piece of code and make sure that it's executed in an atomic way. And you want to make sure that the exit method is only called when the lock has been actually taken. If you don't do this, it's possible that you basically one task say exit and another task is in the middle of the actual code. So there might be still a possibility of corrupting state. Okay, so of course you want to do the same here as well. Okay, you probably can say that writing thread-safe code is not easy, and is certainly going to complicate a lot your code base. Previously, this class was perfectly simple, beautiful, very easy to understand. Now it's kind of a bit of a mess. Try finally everywhere, ifs, statement. So it's not, immediately easy to understand. That's why Microsoft created the lock keyword that allows you to write the same code as we actually did, but in a very nice and concise way. So you can wrap the code that you are interested in just inside a lock statement. So I do something like that. I copy this in here, and then I can remove all of this. And I can do the exact same code here. So I do basically a lock statement. See? something like that. So I wrap the code I'm interested in to protect inside a lock statement, and I always pass the lock object. So under the covers, the compiler translates this lock statement in the exact same way as I've described, using the monitor enter and monitor exit, and using the token acquired variable as well. But you don't need to worry about that internal detail. So if I run this code, you can see that it's protected. So now it's always printed 5,000. So all the tasks always update the balance correctly. And I can prove this to you if you use like a tool like .peek, that is a decompiler. I can right click on a class and ensure the compile sources. There we go. You can see that the deposit method is effectively implemented the same way as I've shown you, just slightly different, just saving the lock object as well locally, and the withdrawn is basically done the same way. So, but you don't need to worry about that. This is what the compiler does under the covers. So under the covers is using the monitor class, but you just use the lock statement when you want to do that. Okay, so let's wrap it up. So when you have code that you want to make sure is thread safe, so that you can use this code in a multi-threaded context, you want to make sure that any variable that is shared that can be updated by multiple threads at the same time is somewhat protected by using a lock statement. There are different ways to achieve the protection, so lock statement is not the only one, but it's definitely the easiest one to use. There are other ways that are either using classes that are already being built for you, like concurrent collections, for example, or you can use interlocks, for example. But the lock statement is certainly one of the easiest way and to implement that, to make sure that a particular piece of code is effectively an atomic operation in a thread safe context. And the nice things about the lock statement is that it's doing quite a lot under the covers, but the syntax is fairly easy to use, and the compiler generates most of the boilerplate code for you. So what are the best practices when you use the lock keyword? First of all, you want to minimize the code that is inside the lock. So all the time you use a lock statement, you're effectively saying that the code inside this lock can only be run by one task at a time. So that effectively reduces the parallelization that you can do, the multi-threading you can do in your application. That's kind of the main reason why you want to use multi-threading, for example. So you want to definitely minimize the code that is protected by the lock. Also, if you can avoid mutable fields like the balance here, if you can make this read-only somehow, and try to make the code as read-only as possible. So if something is only read-only, you don't need to worry about locking it or something like that. Only mutable fields need to be protected. So try to minimize the amount of mutable fields in your class that need to be thread safe. And as I said already, you can consider using other libraries that are already thread safe, like the concurrent collections or interlocks. Also, the other important thing is about the lock object. So the best practice is always to use a private read-only object as a lock object. In this way, you can be sure that only this class can effectively lock using this lock object. So never make the lock object public. Otherwise, you will never know if some other consumer of your class actually use the lock with your lock object. That's why it's a good practice to not use like this. So you could have used this here, but if you do that, this effectively is exposed, is the reference of the class. Anybody using the class could lock this. So you definitely don't want to consumer of your class to lock using the same lock object as you. So the best practice is usually to use a private read-only object for you. Also, you don't want to use anything like public fields or strings types in the lock. So you just want to use a private object. That's really the pattern here. And also, if you use more than one lock object, for example, you want to make sure that you don't cause any deadlocks. So if there is no clear way to avoid that, you need to be careful and use your own thinking and make sure that there is no code path that could cause that. So it's definitely something that requires skills and experience to be able to do that. But obviously, if you can avoid it, just avoid it. But if you really need to design a class that is thread safe, think careful about deadlocks and making sure the code, is robust and can be used in a multi-thread context, and obviously do a lot of testing in order to make sure that that's the case. The lock keyword is definitely a best friend here. If you want to make sure some of your code is thread safe, you definitely need to consider using locks in C#, and that's the recommended way of doing it, unless you can use something already available for you directly. So that's all about locking, and thank you very much for watching.